Welcome back to another video, and thank you everyone for the comments in the first installment on the Yamaha B-6 amplifier. I've taken everything on board that you guys have replied back with, and we are going to attempt to restore this amplifier. I don't know how far we're going to be able to go with it. We're just going to keep going until we run into roadblocks, but we're going to be trying some new and novel things in this episode. We are going to attempt to repair the casting on this because it's broken there and also in this spot here. And as far as I can tell, this is like a die cast aluminium. I have never tried repairing die cast aluminium before, so we're going to be trying that also. I also need to get down to the core of this thing to get to the supply capacitors to work out what is actually in here so we can order new ones. I need to get this main board removed so we can tackle this monstrosity here because this is really bad. There's a lot to do. So this video is going to be over a significant period of time, so you are going to see things change from time to time to time as we jump forward. But we're going to start off with this plate. We're going to get it out, remove the power cord, and get this thing ultrasonically cleaned and work out what it takes to braze or solder aluminium, I guess. So let's get started. Right, so I've taken it out of the ultrasonic cleaner. I've got it about as clean as I can without spending a long time on it. You can see that crack quite clearly. Taken all the paint off, and we're going to just see what happens there. So there's sort of three ways this is going to go. Either this is just going to fail and it's not going to take solder, period. It might just take some solder without anything extra, or I might have to try this flux I got. It is not clear what sort of flux you need for aluminium, and I have a feeling this isn't the exact one that is needed, so I don't want to use this unless I really need it, because I don't know what it's going to do to aluminium. We are going to try some silver bearing solder and see what happens. And I also am going to be using a propane torch to heat this up because this is way too much metal for a soldering iron. So yeah, that isn't going to work. So yeah, it wants to stay in its home, so that's very good, but once it heats up, it might shift a little bit. So we're just going to see what happens, I guess. There is a plastic switch here, which I'm concerned about, so I'm going to wrap this in wet rag to try and keep the heat away from that area and just sort of stay focused in this spot as much as possible. Let's just see what happens. Right, so I went back to the drawing board with this. I was not getting anywhere with this silver bearing solder, with flux, with my torch. It just wasn't, the solder was just balling up and just floating on the surface. There was no adhesion whatsoever. So I went back to researching And I found this on Amazon, and a few people recommended it by Blue Demon, which is some sort of a brazing soldering stick. It's more like a welding stick, to be honest, which apparently will stick to aluminium. And I tried it on this scrap piece here, and it actually worked. I have really good adhesion without flux or anything, just some sanding and then going straight at it, which was really impressive. So that is what I'm going to try. I'm going to have to fillet this out a little bit, I think, because I don't think it's going to want to flow into the joint itself. So I'm going to just cut a bit of a divot in the top of it, and then we'll see what happens once we heat it up. But this has to get really hot, like 400 degrees Celsius hot. So just got to be careful doing this. Right, so there's very few things these days that leave me just dumbfounded, but this is definitely one of them. This stuff is ridiculous. This went on with no flux whatsoever, and it is hard, like really hard. My die grinder was having trouble cutting down this stuff and smoothing it out again, and it's harder than the aluminium it bonds to, which is just absolutely mind-blowing. Is this perfect? No, but this is all going to get repainted again anyway, and I just wanted to... This was more of a proof of concept. I wanted to know if it is possible to repair a crack in aluminium, because there are a couple of threads on this whole thing that may need to be redone, like filled in and then retapped again, and now I know I can do that. And this just came out really good. The problem with it is the heat. It needs a lot of heat to get this stuff to stick. As you saw me trying to get it to go in, it was just blobbing up. And I need to spend a lot more time with it and learn better technique. But the problem is this aluminium just sucks up the heat so quickly that it kept solidifying in balls. And I didn't want to put too much heat into this die casting because there's a plastic switch up here. There's another switch over there. And I just had to be careful not to damage it. So yeah, I reckon if you get it hot enough, you can flow this stuff like butter, and it'll just seep into cracks, and it just goes on really nicely when you hit that sweet spot with the temperature. So yeah, that's all good. This, like I said, this is all going to get repainted, and you won't even see that anymore. This rear one, I decided to epoxy this. This was before I got those sticks because I didn't even know if they were going to work. But this epoxy is really, really hard. I filleted out the metal, so it had a lot to bite onto, and I'm just going to leave this as it is. Problem, I would like to go back and do this with metal, but there is a switch right here that is all plastic, and it's going to melt it if I heat this up, this area. So I think I'm just going to not mess with that. It's already strong, and this area has a switch. This is where all the speaker terminals are, so there's no real need for this to be rigid anyway. Nothing's really bolting to it. I don't even know how it got broken, to be honest. So yeah, I'm just going to leave that, and it'll all be covered up under paint anyway. So yeah, another success. Let's move on to something else. There's the capacitors. Look at that. What the hell? Oh my god. What? What is this? Oh. Okie dokie. So I've got this capacitor bank thing out, whatever you want to call it, and it's definitely done. Like you can see the bulging in the top of those main caps. They're really bad. They still test okay, but they're not far from failing. 12,000 microfarad. I think they're 85 volts. Those ones. These ones are 3,300 microfarad, 80 volt, and these are 50 volt, 6,800 microfarad. So there's two pairs of each. There's a couple of bypass capacitors here by the looks of it. That's all got to be changed. And yikes. Not looking good. I'm going to have to go off camera, think about this. Oh, look at that dint as well. Wowzers. Someone's played soccer with this thing when they couldn't fix it, I think. Yeah, I've got to figure out some new capacitors that are going to fit in here with the lead spacing, the size, the diameter. I hope I can find something. We'll see what happens. I would like to change these rectifiers as well. There's two of them, one on each side. I assume they're doing different rails. I think there's a little one down here as well, like just there. There's a third one. This is wild. I don't know what the hell's going on in here. Lots of scorching. So yeah, I will work on that off camera, and maybe these bypass capacitors as well. We'll change those. So I think we'll have a look at the main board next, and also the power supply, work out what else we need to order, and I'll get like a mini order done and go from there. Right, so this is a mountain of work, and I think we're near the finish line, and I just hope this thing works because it's just so much work, and I'm really over it. The capacitors were a very difficult replacement process because there's nothing directly available to replace what was in there. These Cornell Dubilier capacitors that are in the center, these are the only replacement available that you can get. So if you want to restore one of these things, get these caps, because once they're gone, you're pretty much screwed. All the caps are the same diameter, but they have shrunk a little bit in length, and the pin alignment in regards to these ones, because the other ones are rotated 180 degrees on each leg, so it created a lot of problems with getting these to fit, and I had to basically carve out the PCB and open it right up. As you saw in the video, I made a real mess to make these fit, but overall I think it actually came out pretty good in the end. Had to rebuild all the solder around these caps. Everything is nice and strong. I took off the rectifiers while it was all being ultrasonically cleaned because I don't know if these are sealed rectifier packages. Put the bypass caps back on and we're all good there. Yeah, like I said, the caps are just really specialized and it's a bit of a weird replacement. These caps are domed on the top, so they're about to fail, not looking very good. These capacitors have leaked and have completely failed, so yeah, glad these are all gone. These cardboard things, I didn't even know what they were for, and I almost didn't put them back in, and then it occurred to me that there is a trace running underneath all the capacitors on this board, and there is multiple traces running under the capacitors on this board. So I ended up making new insulators out of sill pad material, and that went underneath the capacitors, and I laser cut it to fit, and it all worked out well. You're going to see more of that in the next video when we do more fabrication type stuff. All the resistors have been changed to metal films. I also raised it off the PCB in some hot areas because those ones have been pretty hot. PCB's nice and dark there. Changed every resistor and we're all looking good there. I'm going to throw all that back in the metal plate now and we're going to close out this video. I think we'll be okay. I don't think we're going to need any spaces or anything because it's got this rubber pad to hold them down. The only other thing I did notice is this has been out a few times by the looks of it by whoever's messed with this. This is about to break off. There's only like 1 or 2 strands holding this on. So I'm really glad I noticed this. So I've got to fix this before this all goes back to... There it goes. Look at that. Dead. All right, let's get this reassembled. Right, so that'll do for one video. I think we've gone way over time with this one. It's been an absolute mountain of work. Some of the keen-eyed among you may have noticed I had a capacitor backwards. I don't know how I did that between all the filming and taking the capacitor in and out for fitting and filling those giant holes. Somehow I managed to just put it in backwards. I've taken it out again. I've put it back in. It's all fixed. Don't worry about it. Yeah, all the caps here that have been changed, all the resistors, lots of stuff to do there. I went back in and resoldered all these binding posts for the AC side, redid the wiring. So there were 3 wires that were broken, these 2 red ones and that black one. The other two were fine. I checked them really carefully, so they're not going to break off. So we're all good there. Bypass caps are back on. We're all good. So in the next video, we're going to tackle this mains input triac board. Oh my God, every time I look at this thing, I hope the ultrasonic cleaner can really work its magic on this, because holy moly, that looks like crap. Why did I take this apart? I don't know. Woof. Bit of a jump cut. I forgot to mention how this base plate went. So this has all been repainted, and I think it came out really good. It's looking amazing. I love this paint that I use. It just looks factory-ish, and it doesn't really leave any obvious signs that it's been repainted. So happy with that. Now, the one bugbear that you're probably noticing is this bridge is gone. It all went completely wrong, unfortunately. The epoxy failed while I had it in the ultrasonic cleaner, so either the vibrations or the heating just caused this to split apart again, and I think it's because there's a thin part and a thick part. There's a lot of stress in this area. I tried to weld it with metal using that same technique, and that failed also because this thin area kept shifting at a different rate to the main chassis. And I kept trying and trying, and this whole thing just melted into a puddle eventually after a lot of heating. And yeah, even after removing all the switches, because I got sick of messing around with the switches, so I just bit the bullet and took them out. So anyway, this is gone now, and honestly, I should have just done it in the beginning, because it's not a real structural piece. I can 3D print a new speaker terminal assembly, which is what we're doing anyway, and I will build it up to the top here and reinforce this section. So yes, it's gone, but it's not a big deal, I don't think. We'll be able to 3D print something to fix that up. So yeah. Yeah, so we're going to tackle that. We're going to be doing some fabrication again. We're going to make some new binding posts for the speaker terminals. We're going to laser cut insulators for everything. It's going to be quite a good video with 3D printing, fabrication, all that fun stuff. And that's for the next video. I would like to test this also, because I really want to test it even after doing all that, but this is already in bits from measuring components, so we have to do both of them, I think, before we can do any testing. But that is next up once we get that board done and test these two parts together and make sure we haven't done something really bad. Anyway, stay tuned, and we'll be back with another video soon.